You're lying in a bed at 3 in the morning. The room is quiet, and a cat you barely know pushes the door open, jumps up, and settles against your leg. He has done this 99 times before. 99 times, the person died within a few hours. His name was Oscar. He lived at a nursing home in Providence, Rhode Island. And in 2007, a doctor wrote about him in the New England Journal of Medicine. Not a tabloid. One of the most respected medical journals on Earth. So here's the question. Do animals know when you're about to die? And if they do, what are they actually picking up on? Because it isn't magic. It's chemistry. And it is far older than you are. Think about how strange this is. A cat has a brain roughly the size of a walnut. It cannot read a chart. It has no idea what a kidney is. It doesn't know the word hospice. And yet, it walks past 40 rooms, ignores every single one, and picks the one person who has hours left. You'd think that's impossible. You'd think it's a coincidence people remember and then exaggerate. And honestly, part of it might be. But then you look at the dogs. Dogs that sit down and refuse to move 10 minutes before their owner has a seizure. Dogs that sniff a urine sample and pick out breast cancer that no scan has found yet. Dogs that flag a tumor through a piece of gauze. These aren't ghost stories. These are published studies with controls and blind trials. Which means something real is happening, and the real version is stranger than the ghost story. Here's the thing nobody tells you. This isn't one ability. It's never one thing. It's a stack of separate systems, some of them hundreds of millions of years old. And each layer is weirder than the one before it. We're going to go through them one at a time. Smell first, because that's where most of it lives. Then illness, then the cat, then the oldest chemical signal on the planet. And at the end, there's a twist about you that I saved for last, and it's the part that actually changes the question. Let's go. Start here, because everything else depends on it. You are not a solid object. You are a slow leak. Every second, your skin, your breath, and your sweat are releasing hundreds of volatile organic compounds into the air around you. Chemists call them VOCs. They're just tiny molecules light enough to float. You produce a cloud of them constantly, and that cloud is basically a live readout of your metabolism. You can't smell it. Your nose has roughly 6 million olfactory receptors. That sounds like a lot until you meet a dog. A dog has more than 10 million receptors and around 1,094 working olfactory receptor genes. That's about 3 times your genetic hardware for smell. And the part of the brain devoted to processing it is proportionally enormous. The result is a sensitivity gap that's hard to hold in your head. Estimates put a dog's sense of smell somewhere between 10,000 and 100,000 times better than yours. In lab conditions, dogs have detected target compounds down to the parts per trillion range. One study measured thresholds as low as 1.5 parts per trillion. Let me put a number on that. 1 part per trillion is roughly 1 drop of liquid in 20 Olympic swimming pools. Your dog can find that drop. You can't find the pool. So when people say a dog senses something, that word does a lot of unfair work. Sensing sounds mystical. It isn't. The dog is reading a chemical document that you are writing every second of your life in ink you can't see. Think about that for a second. And it isn't only dogs. Cats are running similar hardware. Bears are running better hardware than dogs. A pig can find a truffle buried under a foot of soil. Every animal you've ever shared a room with was getting a version of you that you have never once experienced yourself. Try to imagine it from the other side. You walk into a house and see furniture. A dog walks into that house and gets a timeline. Who was here? How long ago? What they were carrying? Whether they were nervous. To a nose that good, the air isn't empty. It's crowded and layered, and it has a past tense. And now ask the obvious follow-up. What happens to that document when your body starts to fail? It changes. That's the answer. When cells go wrong, their chemistry goes wrong with them. And the leak coming off your body changes composition. Cancer is the clearest example we have. Tumor cells burn fuel differently than healthy cells do. They break down molecules in ways your body doesn't normally bother with. And the byproducts end up in your breath, your urine, and your sweat. Which means, in principle, cancer has an odor signature. For a long time, that was a fringe idea. Now it's a research field. In one preliminary breast cancer study, a trained dog was given urine samples in a double-blind setup and identified the cancer samples correctly in all 40 runs. Sensitivity 100%, Specificity 100%, 40 for 40. In January 2026, researchers reported that trained dogs could detect hemangiosarcoma, an aggressive cancer of the blood vessels, purely by scent. Across all trials, the dogs got it right around 70% of the time. Not perfect, but hemangiosarcoma is a disease that usually announces itself by killing, so 70% from a nose is remarkable. And it's scaling up. In 2025, a breath-based study running over 1,000 samples was presented at the American Society of Clinical Oncology meeting, testing canine olfaction for detecting multiple cancers at once. Now, dogs are inconsistent. Results swing wildly between studies, between dogs and between days, because dogs get bored and distracted and have opinions. But the pattern underneath is solid, and it's the important bit. The smell is real. The information is genuinely in the air. The dog is just the least reliable instrument we've ever pointed at it, which brings up something sharper. Cancer takes months. What about something that happens in minutes? You've probably seen the videos. A dog suddenly stops playing, walks over, and plants itself against its owner. A few minutes later, the owner has a seizure. It looks like precognition. For years, nobody could prove there was anything there at all. Then in 2019, a team from the University of Rennes in France and Medical Mutts, a service dog organization in Indianapolis, published a study in Scientific Reports and finally settled at least half of the argument. The design was clean. They collected sweat samples from 7 people with different types of epilepsy, taken during different activities, resting, exercising, and during an actual seizure. Then they took 5 mixed-breed dogs, all of them adopted from shelters, and asked them to pick out the seizure sample. 3 of the dogs, Casey, Dodger, and Zoe, got it right 100% of the time, and did it in under 5 minutes. The other 2 scored at least 67%. Every dog performed above chance across repeated trials. That result did something specific. It proved that a seizure produces a distinct change in human body odor. Before that study, that was an assumption. After it, it's a finding. Here's the honest limit, though, and the researchers said it themselves. Showing a seizure has a smell is not the same as showing a dog senses one coming. Those are 2 different claims, and only one of them is nailed down. The dogs in that study were smelling seizures that had already happened. So hold that thought, because it's exactly the problem we run into with the cat. Steerhouse Nursing and Rehabilitation Center, Providence, Rhode Island. A 3-story building with a dementia unit on the 3rd floor. In 2005, the staff adopted a kitten named Oscar. Oscar was not a friendly cat. That detail matters. He didn't want to be held. He'd spend his day pacing the corridor, ignoring residents, ignoring visitors, generally being unimpressed by everyone. And then, every so often, he'd walk into a room, jump onto the bed, curl up next to a patient, and stay. Staff noticed the pattern. When Oscar settled on a bed, that resident usually died within a few hours. In 2007, Dr. David Dosa, a geriatrician at Steerhouse, described this in the New England Journal of Medicine. At that point, he counted 25 cases. By 2015, the count being reported was around 100. Families started to treat Oscar's arrival as the signal to come in. Staff started calling relatives when the cat lay down. So what was he doing? The leading explanation is chemical. As cells die, they release ketones and other compounds with distinctive Swedish odors. And a cat's nose is far better than ours. Oscar may simply have been walking toward a smell. The competing explanation is much more boring. People in their final hours stop moving. They stop being repositioned, stop being spoken to, stop generating noise. The room goes still and warm and undisturbed. That is, if you're a cat, an outstanding place to sleep. Oscar may have been choosing the quietest bed in the building. And the quietest bed in the building belonged reliably to the person who was dying. Both explanations fit. Neither has been tested properly. Hold on to that, because we're coming back to it. And I want to flag something about the reaction to Oscar, because it says a lot. Nobody at that nursing home found him frightening. Families asked for him. Staff started leaving doors open so he could get in. A cat that showed up as a death omen became, very quickly, the thing people wanted in the room. That's worth sitting with. Whatever Oscar was detecting, the humans around him turned it into something useful. A few hours of warning is a phone call made in time. It's a daughter getting there before it happens. Whether the mechanism was ketones or a warm, quiet bed almost stops mattering at that point. There's a category we skipped, and it's the most practical one. Medical alert dogs are trained to flag things that aren't death, but are the road to it. Diabetic alert dogs are the classic case. When blood sugar drops dangerously low, the body's chemistry shifts, and the compounds in a person's breath shift with it. A trained dog can flag that drop before the person feels it. People with severe hypoglycemia unawareness, who genuinely cannot tell when they're crashing, use these dogs as a nose they don't have. And this is where the whole subject gets clearer. The dog isn't predicting a coma. The dog is detecting a chemical state that leads to one. That distinction is the entire subject in one sentence. Animals aren't reading the future. They're reading the present in a resolution you don't have access to. And the present, if you can read it well enough, tells you a lot about the next 20 minutes. Let's go much further back. Long before cats, long before dogs, long before us. Take an ant colony. If an ant dies inside the nest, other ants pick up the body and carry it out to a refuse pile. Efficient, hygienic. Obviously, they can tell it's dead, right? Not exactly. What they can tell is that it smells of oleic acid. Oleic acid and linoleic acid are fatty acids that leak out of a body when it dies, and its tissues begin to break down. Researchers call these signals necromones, chemical death cues, and they show up right across the arthropods. C. David Rollo at McMaster University documented crickets avoiding surfaces and shelters, treated with nothing but these fatty acids. Cockroaches do it. Springtails do it. Social aphids use linoleic acid to identify their dead. And here's the bit that gives the game away. In the classic experiment, you dab a tiny amount of oleic acid onto a perfectly healthy, living ant. Its nestmates immediately pick it up and carry it to the corpse pile. It struggles. It's clearly alive. Doesn't matter. It smells dead, so it's dead. And when it climbs back in, they carry it out again. That is not understanding. That is a chemical trigger pulling a lever. And it's ancient. This system predates brains that could hold an idea like death. Vultures run a version of the same thing. Turkey vultures locate carcasses by smell, homing in on ethyl mercaptan, one of the key compounds released by decomposition, which produced one of my favorite stories in this whole subject. In 1938, Union Oil was struggling to find leaks along a gas pipeline in California. Someone noticed vultures kept gathering over the leak points. So the engineers deliberately pumped ethyl mercaptan into the line, went outside, and watched for circling birds. The vultures found the leaks for them. The vultures were not detecting gas. They were detecting death and being wrong about it. Beautifully, usefully wrong. So far, everything has been chemistry. Molecules in, behavior out. But some animals are clearly doing more than that. Crows. In 2015, Kaylee Swift and John Marsluff at the University of Washington published a study in the journal Animal Behavior on what people call crow funerals. The setup: a person stands in a Seattle neighborhood holding a dead, taxidermied crow. Local crows arrive. They gather. They scold. They make a lot of noise. But the crows weren't grieving. They were taking notes. Swift found that the crows associated that specific person with danger after one single exposure. And they stayed wary of that person for around 6 weeks. A nearby control species, the rock pigeon, did nothing of the sort. That's a dead body being used as information, not as a loss, as a warning about a predator. Elephants go further. Schiffer Goldenberg and George Whittemire reviewed 32 documented observations of wild elephant carcasses drawn from 12 separate sources across Africa. The consistent finding: elephants approach their dead, touch them, and investigate them. And they do it at every stage of decay, from a fresh body all the way down to sun-bleached bones scattered in the dirt. The detail that stops you is this: they do it even for elephants they never knew. It isn't only family, it's broad general interest in the dead of their own kind. Nobody can tell you what that means from the inside. But the behavior is real, and it is documented, and it's a long way. From an ant reacting to a fatty acid. There's a whole scientific field for this now. It's called comparative thanatology, which is a very serious name for the study of how animals respond to death. And the working conclusion, so far, is that death recognition isn't one skill, it's a ladder. At the bottom rung, you've got the ant, pure chemistry. No comprehension. Carry the smell outside. Higher up, you've got the crow. using a corpse as a data point about a specific dangerous human. Higher still, the elephant, returning to bones years later for reasons nobody has managed to pin down. And somewhere at the top of that ladder is you, the only animal that knows the ending in advance, and spends its whole life doing something about it. Same ladder, though. That's the uncomfortable part. Now let's be honest, because this is where these stories usually go off the rails. Almost none of the death prediction cases are properly tested. Oscar is the biggest one, and Oscar has never been through a controlled trial. Everything we have is staff recollection at a single nursing home, described by one doctor who worked there. That is not a knock on Dr. Dosa. It's just what the evidence is, and human memory is a terrible instrument for this. If a cat lies on a bed and someone dies, that becomes a story people repeat for years. If the same cat lies on a bed and nothing happens, nobody remembers it by Thursday. We count the hits. We quietly bin the misses. Every psychic, every prophecy, every gut feeling runs on that same engine. There's a second problem. The dying were probably easier to identify than we think. Staff at a hospice know roughly who is close. They change routines. They lower voices. They move chairs into rooms. A cat that pays attention to human behavior, which is every cat, could be reading the staff, not the patient. So the correct position isn't animals know. It's narrower than that and more interesting. The chemistry is real and measurable. The prediction is not proven. And the difference between those two sentences is where all the honest work is. One last thing I saved for the end, and it's the strangest part of all of this. When a body decomposes, it produces two compounds with unforgettable names, putrescine and cadaverine. They are the smell of death in the most literal chemical sense. In 2015, Arnold Wiseman and Ilan Shrira at the University of Kent ran 4 experiments on putrescine and published them in Frontiers in Psychology. They exposed people to it in tiny quantities, sometimes at levels the participants consciously noticed. Sometimes at levels so low they had no idea anything was there at all. The results were consistent. Brief exposure to putrescine made people more vigilant. It pushed them toward getting away from the situation. And when escape wasn't an option, it pushed them toward aggression instead. Vigilance, then flight, then fight. A full threat response. Now here's the part that matters. The participants had no idea why. Almost nobody on Earth knows what putrescine actually smells like. Nobody in that study consciously connected it to death or danger. They just found themselves more alert and more inclined to leave, and they could not have told you the reason. You have that system. Right now, it's running in the background while you watch this. Separate work has gone looking for the specific human receptors that respond to these death-related diamine molecules, because the response is real enough to have a mechanism worth hunting for. So we've had this backwards the entire time. We keep asking whether animals can sense death on us, as if we're the neutral observers and they're the mysterious ones with the sixth sense. You're not surrounded by animals that can smell death. You're one of them. The dog is better at it. The vulture is better at it. The ant is dumber and faster about it. But the machinery is the same machinery, and you inherited yours from the same place. They inherited theirs. It's just quieter in you. It doesn't send you a message. It sends you a mood. So, do animals know when you're about to die? They don't know, not the way you mean it. There's no calendar, no premonition, no small furry oracle. What there is a body that changes its chemistry when it starts to fail, and a world full of noses good enough to read that change, while you are still standing there talking about the weather. You've spent your life assuming you're the one doing the observing. You're not. You're being read constantly by almost everything with a nose. Most of it is boring. What you ate, where you've been, how frightened you are, and occasionally, in the last hours, something else. You are not a solid, silent thing moving through the world. You're a signal, and you have always been one. If this one got you, there's a whole channel of them waiting.